This is a piece of C language code. How does it make the machine run? For example, we can use GCC compiler to convert the source code into assembly code first. Here, -s is the parameter for generating assembly. -o2 is just for optimization parameter. Just ignore it. Then, replacing -s with -c will generate machine code. Finally, it is merged with Unix library function code, and finally fed to the CPU for execution. Today we use assembly to understand the stack of C programs at runtime. The assembly here is based on the IA32 instruction set. IA32 is also Intel architecture 32-bit. This processor series is commonly known as x86. When the CPU is running, it has a small amount of small storage area called a register. In IA32, the names of registers all start with E. Most of them are universal. Only two are special. ESP stores the stack pointer, and EBP stores the frame pointer. They will be introduced in detail later. When a program is running, these low variables will be stored in an area of memory called the stack. The stack is a basic structure in the data structure, with only two operations. One is push into the stack, and the other is pop out of the stack. But in memory, the stack is upside down, that is, increased from high address to low address. In this way, the pointer at the top of the stack is called the stack pointer and points to the bottom of the stack. The register ESP is used here, which is the abbreviation of stack pointer. For example, there are three registers. They store three different values. 0x represents the meaning of hexadecimal, which can be ignored here. There is an assembly line called push EAX. That is, the value in the register EAX is pushed onto the stack. The air here means long, which occupied a size of 4 bytes and is commonly known as a double word. It can actually be equivalent by the other two line assembly. Now there is a stack in the memory. ESP is a stack pointer pointing to the top of the stack, and the address is 0x108. So in the first line, reduce the stack pointer ESP by 4 bytes. The dollar symbol represents an immediate number, which means just a number. Then in the memory, the stack pointer moves down 4 bytes, where a cell is just 4 bytes. Note that the stack is extended from the high address to the low address. Then in the second line, assign the value of the register EAX to the memory address pointed to by the stack pointer ESP. The brackets here are to treat the value in the register as the address of the memory and find the corresponding value according to the address. Then in turn, pop EDX pops the top of the stack and assigns it to the register EDX. Equivalent to these two lines, first, in the first line, assign the value 0x123 pointed to by the stack pointer ESP to the register EDX. Then move the stack pointer ESP up by 4 bytes. The original value does not need to be changed, but it is already in an empty area. Now we start from C program to understand the running state of the stack. The main function is called caller. It will call the swap add function, swap the two parameters, and then add them. The basic unit of each operation is called a procedure, which is specifically a function here. When the caller function is running, there is a corresponding area in the running stack in the memory, which is called a stack frame. Before calling the swap add function, There are already local variables in the stack frame. The current stack pointer is stored at the top of the stack by the register ESP. The start address of the main function corresponding to the stack frame is stored by the frame pointer, which is the register EBP. Before calling swap add, take the address of the variables arg1 and arg2 as the calling parameters. Let's look at the corresponding compilation. First, add the address of EBP-4 to the register EAX and store it temporarily. Then push the temporarily stored value onto the stack, which is the address of arg2. In the same way, the last two lines are to push the address of arg1 onto the stack. Finally, use the call command to call swap add. Save the address of the next line of code after the code as the return address, and then push the stack. Now the swap add function is officially executed. First, create a stack frame corresponding to the swap add function. According to the assembly, the register EBP frame pointer is pushed onto the stack. Here EBP points to the starting address of the previous stack frame. Then, the address of the stack pointer ESP is assigned to the frame pointer EBP. That is, the frame pointer also points to the top of the stack. Save the register EBX again, because it may store the variables of the previous function. Next is the assembly corresponding to the swap add function body, which will not be expanded here. At the end of the final call, by manipulating the stack pointer and frame pointer, restore to the main function caller and continue execution. Alright, this video is over here, and we will see you in the next issue.